Okay, now we're now on lesson 4 in our discussion on matrices, and there's some important topics that we're going to talk about. We're going to build on what we've already learned. I want you to leave today with the understanding of how to find the determinant for a 2 by 2 matrix. All of our matrices in this lesson will be 2 by 2. Anything higher than that, it's really better to use a graphing calculator, which you're not required to have. So we're going to focus on 2 by 2 matrices, how to find those determinants, and then how to find the inverse of a 2 by 2 matrix. So let's start with this idea. Roman numeral 1 is going to help you with the first 3 problems of the assignment. How do I know that 2 matrices are inverses? Well, I just want to relate it. There's really nothing for you to write on this first slide. The red section of this slide represents an illustration of what we call the multiplicative inverse property. If I multiply a number times its inverse, or its reciprocal, I always get 1. And the number 1 in this case is called the multiplicative inverse identity element. Well, let's relate that to the green. I just made up this matrix using variables. Here's a matrix on the left, a 2 by 2, multiplied by another matrix on the right, assuming these are inverses. When I multiply 2 matrices that are inverses together, I get, instead of just a single number 1, I get what is known as the multiplicative identity matrix. And it always looks like this. If I were multiplying 2 3 by 3 matrices together and they were inverses, then the result would look like this. A little different, but you see how we have those diagonal ones starting from this top left all the way down to the bottom right, and the 2 by 2 illustrates that as well. So this is always called the multiplicative identity matrix. And so with that in mind, I'm going to show what you're going to do on 1 through 3. I'm going to show that these 2 matrices, A and B, are inverses. And to do that, we need to remind ourselves how to multiply 2 matrices together. So here's my A matrix. Here is my B matrix. And remember, I know it's been a few days, but when we multiply matrices together, it's always the row of the left matrix times the column of the right. So to get this top left element of the product, I'm going to do 2 times 2. Remember, we always add when we're multiplying matrices together. And now I'm going to multiply 3 times negative 1. All right, and when I put these together, 4 plus negative 3 is 1. All right, now I'm going to work on this row 1, column 2 part of my answer. So I'm going to use row 1 times column 2. So that's 2 times negative 3 plus 3 times 2. Negative 6 plus 6 is 0. All right, now let's work on the bottom row of our product. Since this is row 2, column 1, so I'm going to use row 2 multiplied times column 1. 1 times 2 plus 2 times negative 1. 2 plus negative 2 is 0. And then finally, to get row 2, column 2 of the product, I'm going to use row 2 times column 2. 1 times negative 3 plus 2 times 2. Negative 3 plus 4 is 1. Remember, when we're trying to determine whether matrices are inverses, we should always come up with this matrix, or the identity matrix for multiplication. This is called the identity matrix. And so that's what you're going to do basically on problems 1 through 3. Multiply 2 given matrices together and prove that the identity matrix will be the result, which proves that they are matrices, or that they are inverses. All right, Roman numeral 2. The next topic is, how do we find the determinant for a 2 by 2 matrix? Well, for purposes of this class, the determinant is going to be very helpful in helping us find the inverse so we can solve some problems. When you get to future math classes, that's also going to be helpful in helping you find the area of certain shapes. When you get to calculus, pre-calculus, you're going to learn this idea of vectors, and this idea of determinants will be very useful information in future math classes. But for today, I want you to know how to find it. Pretty simple, really. There's nothing to write on this slide. The way we find the determinant of a 2 by 2 is we multiply these two elements together that I've labeled as A and D, A times D, and then I always subtract. When you're finding the determinant, think of the D in difference. Difference means subtract. You always subtract, common mistake people make. You subtract the product of the other two elements, B and C. All right, so with that said, let's apply this little formula that I've given you to find the determinant of a 2 by 2 matrix. So Roman numeral 2a, you'll be doing this same practice with these problems. Find the determinant. So I'm going to multiply what I call the A and the D elements together. 7 times negative 9. You always start there. And then you always subtract the product of the other two elements. Negative 5 times 8 is negative 40. And I put these together. Subtracting a negative number, of course, is really addition. So the determinant for Roman numeral 2a is negative 23. I wrote it differently on letter B. Letter A actually uses the abbreviation for determinant and then uses the square brackets for a matrix. Notice I didn't use that wording or that abbreviation, and I have these single lines that look like absolute value. Well, this is just another way of asking for the same thing. This means find the determinant of this matrix. All right? So I multiply 4 times 6, 24. Then I multiply 5 times negative 3, and I always subtract. So 24 minus negative 15 is 39. So that's my answer for letter B. Any questions so far on how to find the determinant of a 2 by 2? Follow carefully this little procedure and you'll have it. A times D first, then subtract the product of B and C. Okay, the reason why we need to know how to find the determinant is because in this part of our lesson we're going to learn how to find the inverse. It's not as simple as it is in real numbers where you can just take a number and flip it over. We're going to have a process, and this is something that's going to take a little bit of practice. So drill it with purpose when you do these homework problems. First of all, a very important statement is made here with my star. There are some matrices that do not have inverses. And here's how you'll know. In order for a matrix, a 2 by 2, or any matrix for that matter, for a matrix to have an inverse, it cannot have a determinant of 0. Here's why. Here is the actual formula that I'm going to work with you in determining how to get the inverse of a matrix. Notice I'm always dividing 1 by this determinant, whatever that number is. Well, what if that number is 0? Can I divide by 0? No. Division by 0 is undefined. It's not possible. So if you're trying to find the inverse of a matrix and the determinant ends up being 0, you're going to say that that matrix does not have an inverse. It's not possible. But if the determinant is anything besides 0, then we can come up with it, and here's how we're going to do it. So what I have given here is going to be very, very important in some of your homework problems. This is the process, or if you want to call it the definition, of how to find the inverse of a particular matrix. Now what I've given here, we've talked about this in the past, this little -1 subscript always stands for the inverse of. So I've given you a matrix called A using variables. This would be the inverse of A. Now as you look at the original matrix called A, and you look at this other matrix that's involved in the definition, give me 2 things that you noticed that changed from here to here. Keegan. Okay, very good. We switch places with these elements called A and D. Very good. Somebody else give me the other change that was made. Kennedy. Okay, I'm going to say it this way. B and C change signs. So if they're positive in the original, they'll become negative or vice versa. Once we've made that change, then we're going to multiply by this fraction 1 over the determinant. Of course, the determinant can't be 0. All right, so let's practice this. The directions here say to find the inverse matrix if it exists. It could be that there is no inverse. Well, to find that out, we need to first find the determinant. So, John, help me out with the determinant here for this matrix. How would you find it? Okay, negative 2 times negative 7, that's 14. What operation? Okay, and then what? 4 times 3 or 3 times 4 is 12. That means the determinant is 2. So I know an inverse exists. Using that definition that I gave you on the previous slide, here's how we're going to find it. 1 over the determinant. That means 1/2. Always do the determinant underneath 1. Remember, to get the inverse, I'm going to have to switch places with these elements called A and D. So I'm going to do that first. Here I have switched A and D. I just pick them up and switch them. The other two change signs. They don't leave their spot. We just change their sign. And now, Riley, I'm going to multiply 1/2 times each one of these. And what do I get? So this is considered to be my inverse. So if I were given a matrix called E, I'm going to call this the inverse of E. And that would be my final answer. Any questions on how to find the inverse of a 2x2 matrix? Why did we find it? It's part of finding the inverse. Remember, it's this number here. So yeah, you need to do that first because, well, that kind of segues into letter B. Matthew, help me out with finding the inverse here. Let's first find the determinant. Okay. Okay. So, is there an inverse? No. Can't divide by 0. So if this were a homework problem, it'd be very nice. You would just say no inverse and move on. If the determinant is 0, there is no inverse. Questions? All right, we're building. Now, this is the last type of problem that you're going to have on this homework. We're going to solve matrix equations that involve multiplication. Well, let's go back in our experience for just a minute. Go back to your Algebra 1 or maybe even pre-algebra. You don't necessarily have to write this down, but if I ask you to solve for x here, Sam, doesn't relate to this, but let's just go back. Solving for x here, Sam, what would you do? 3 over 2. 3 over 2 is considered to be the what of 2/3? The reciprocal, or we might use the word inverse, okay? Now, why did you multiply by 3 over 2? Because that's how we undo multiplication by 2/3. All right? Remember that? Well, in that same way of thinking, we need to undo multiplication by this matrix by using the inverse matrix. All right, so now you know how to do that. I need for you to work on now, go ahead and start. I need for you to find the inverse of this matrix on the left that's being multiplied by x. And it starts with finding the determinant. So I'll get a helper here. Izzy, tell me when you get the determinant for this matrix. Good. It's always great when the determinant's 1, because that means when I go through my process or that definition, I'm doing 1 over 1, which is essentially multiplying by 1. Okay, before I multiply though, I need to change this matrix up. So Sam, tell me what this is going to be in here to get the inverse. How will I change this up? Okay. Okay, once again, you change places with these that are called A and D. You switch the signs of the other. We're multiplying by 1, so that is the inverse. Any questions so far? Well, I am going to use it. Remember in the other problem, Sam said multiply by 3/2 on both sides. Well, I haven't multiplied by anything yet. All I've done is found the inverse of this matrix. Well, now I'm going to multiply by the inverse just like we did with 3/2. We're going to multiply this inverse times the matrix on the right. Sorry. Now, I'm going to save you a little bit of time. I'm not going to make you show this left matrix being multiplied by the inverse, but I would like for somebody to tell me what the result should be. If you multiply a matrix times its inverse, going all the way back to the beginning of this lesson, what should the answer be? There we go. 1, 0, 0, 1. Remember, that's the multiplicative identity matrix. Don't have to do that as part of your work, but you will need to multiply on the right. What I'm about to say is crucial, and it's a commonly made mistake, so you might want to write yourself a note. Do you notice how that I have, when I'm setting up multiplication here, inverse times the matrix on the right side of the equation? I purposely, intentionally wrote the inverse on the left before I start multiplying. That has to be true. If that's not true, you're going to get the wrong answer. Matrix multiplication is not commutative. So I'm going to make a little note. I suggest you do the same. Inverse always on the left when you're multiplying these together. If you change places, if you put the inverse on the right, you're going to miss this. You're going to get the wrong answer. Okay, take 30, 45 seconds, multiply these two together. I'm going to come back to you and see what you got. Okay, multiplying two matrices together, I do row times column, so this top left element should be easy. Negative 5 times 0 plus 4 times 0, 0. Here I'm doing negative 5 times negative 22, 110 plus 4 times negative 28, negative 112. So positive 110 plus negative 112 is negative 2. Okay, now let's work on the bottom. Negative 4 times 0 plus 3 times 0, 0. Negative 4 times negative 22, it's positive. 88 plus 3 times negative 28. Sam, what's that? Okay, so we got 88 plus negative 74. It should be 84. Yeah, it's negative 84. 88 plus negative 84. And that's my answer for x. Now, how can I know if I'm right? If I take this matrix and I put it in here and I multiply, then I should get this result. So I've got confidence that I did the right thing. Okay, so that wraps up our lesson for 4 for matrices, and that is the assignment. We will check that out and contact me if you have any questions.